Hey everybody, Joe here. Want to check out a puzzle um that was suggested to me by Patrick Junke called Heavy Computing. I've done this a couple of tries and I keep making an error over here on one of the later parts. So, I want to give it a new go as I am doing something wrong early on, I believe. But let me read the rules here to you. And an overview of the three tasks of this puzzle. First, our first step is to color the maze, and then we do some arithmetic conversions, and then we resolve the arithmetic-based Sudoku variant. For the detailed instructions, our first step is hardware to build the circuit. The 9 by 9 grid contains this 9 by 9 up here, the normal looking Sudoku puzzle. Contains a maze, a unique area of orthogonally connected cells, and then all other cells are walls. So the maze will be all orthogonally connected. No 2 by 2 block of cells within the grid can be entirely composed of maze or wall. An arrow indicates a dead end in the maze and points to the only cell to which it is connected. And all arrows are given. So these arrows are the only dead ends. Each dotted region contains exactly 4 walls and 5 maze. So the dotted regions are like the killer cage looking things, as you can see, scattered around. And then step 2, okay, we're going to do step 1 first. We are going to build the circuit. Figure out where, let me turn this down a little bit, or attempt to, right there. Okay, so our first step is to construct the maze, and the arrows, plus the way they are pointing, are all maze cells, and the arrows can be the only dead ends in the puzzle. And they are in fact dead ends. So nothing else can connect, no other maze cells can connect to the arrow. So those are all wall. Okay, now all of these maze cells also touch orthogonally, so this one is going to have to eventually get out. These two are eventually going to have to get out, and that's it for being trapped for now. So down here in this region, in this dotted region, we have 5 maze, which is our maximum. Each dotted region contains exactly 4 wall and 5 maze. So we have our 5 here, so we know that one is wall. And now we know this needs to be yellow to touch orthogonally. And then in this region we have our 4 gray. So we know that is yellow, because it must have 5 again. And we have 3 in that one. We have 3 yellow, and we have 3 of each in that one. Oh, we have 4 in this one. We have 4 wall in this region up here. So that one is yellow. 2, 3, 4. These two little regions up here, they either get out there or there. I guess they could get out both, though. As those are in different regions. But if we were to speculate if that is yellow, so that would be the 5th yellow, and those two would be gray, and now this way is trapped. But that would make this yellow as well. But that would also be a dead end. And all the arrows are given. So that would have to be an arrow. So that is in fact not yellow, and it is gray. And now this has 3. So this, well, no. I mean, that is true, but the other thing that is true is these two regions only have one way out to be orthogonally connected to its friends, and that is here and here. So it must go out that way, and it must come up. And now we have 5 yellow in that region. We need our 4th wall. This will have to get over. And that one has to be yellow too, because we can have a 2x2. And this one has to get out. So all 3 of those are now yellow. This is 1, 2, 3, 4. That has 4 yellows in it, and these still need to be out. So since all of these are of the same region, it has to just go straight across. As in, if that one was yellow, then the rest of these would have to be wall, and it would be trapped. Same for that one. And if this was yellow, then we still wouldn't be connecting. We have to connect orthogonally, we cannot connect diagonally. So that one is yellow, and then those 3 are therefore gray. And that'll be our 4 gray in that region. Now this one is trapped at the moment, it needs out. And we have 1, 2, 3, 4, 5. So that one is gray. Now this region here needs out there. And then we cannot dead end. So that is gray. Now it needs to come out here. So that is 1, 2, 3, 4, 5, which is good. This needs to come on out. It's gotta get out to its buddies. This one is needing out as well. And we have 3 here. We have 3 yellow in this one already. So we can only have 2 more, but we also know that these are isolated at the moment, right? These are not touching the rest. So we only have 2 cells, and we know we have to get up to this box 4 here. So the only way we can do that is if we go straight up. We can't have 2 more touching this side of the board any other way. So those have to shoot straight up, and that is 5. The rest of these will be wall. This one has to come on out now again. And this one has 3 already also. So again, we only have 2 more yellows, and we have to get up to this top area orthogonally. So the only way we can do that is if we just shoot straight up again. And then that's going to make all of these walls to give us 4 wall in this region with 5 yellow. So this should be our completed maze, and all of the arrows are our only dead ends, which is true because all arrows are given. So our maze is complete. And now we go to step 2. We turn on the circuit and collect the raw data. So in each cell crossed by... Oh, in each cell crossed... Okay, yeah. In each cell crossed by a horizontal or vertical line, right? 1 if the cell is a wall. So, if we were to just select all of the gray cells that have a line in them, and I think that's all of them, then we can just write a 1 there. And then if we, for all of our maze cells that are crossed by a line, I think that is all of those. We write a 0. Okay. Now reading the digits along horizontal lines from left to right and along vertical lines from top to bottom gives you now binary numbers. And to convert the raw data into usable data, we are converting the binary numbers into decimal numbers. To convert a binary to decimal, multiply each digit by 2 to the nth power, wherein is the position from the right, starting at 0, then sum the results. And here is an example. Basically binary is, we'll use this line here for an example. It starts at 1, or these are like on or off, right? So all of them that are 0 are going to end in 0, but it's powers of 2 basically. It's in 1, 2, 4, 8, 16, 32. Because this top one would be 2 to the 1, 2, 3, 4, 5 to the 5th power. So 2, 4, 8, 16, 32. So this one here is 32, for instance. Hopefully that makes sense. So basically the zeros are off and the ones are on. So this one would be 1, 2, 4, 8, 16, and 32 are on, which is 56. One, 2, 4, 8, 16, and 32. Okay. So let me start up here, I think. Even though I started there. Actually, I'll just keep going over. So this one is 32 as well. 32, 16, 8, 4, 2. So 32 plus 2. Just want to make sure that is 1, 2 is on 4, 8, 16, 32. 34. That is correct. This one 1, 2, 4, 8, 16, 32, 64, quite simply, as this one is the only one that is on, that is in the 2 to the 6th power position. This one goes here to here, that is 1, 2, that is 3 so far, 4, 8, 16, 24 plus 3 is 27. 1, 2, 4, 8, 16, 24 plus 3. This one is here. It's 1, 2, 4, and 16, which is 22. And this one is 32 at the top, 16, 48, which is 1, 2, 4, 8, 16, 32, 48. Now, for the horizontal rows, we have 1, 2, 4, 8, 16, and 32 again, which is 48, 16, and 32. 1, 2, 4, 8, and 32. 14 plus 32 should be 46. 30. 1, 2, 4, 8, 16. 16, 24, no. 1, 2, 4, 8, 16. 16 plus 8 is 24, 28, 30. This one is 1, 2, 4, 8, 16, and 32. 48 plus 1 is 49. This one 1, 2, 4, 8, 16, 32, 64. That should be 68. 1, 2, 4, and 64. This one 1, 2, 4, 8, and 16 is 24, 26. 1, 2, 4, 8, 16, 24 plus 2. this one. It's 1, 2, 4, 8. 1632. So that's 41. Which is 1, 2, 4, 8, and 16. No. 1, 2, 4, 8, 16, 32, 41. Okay. Okay, now we clean the data. Inside the grid, erase the zeros and ones. You may also remove any coloring. So we quite simply select everything. And delete it. And then our step 5 is software. Test a beta version of your Sudoku program with this Sudoku variant. With the rules, each 3x3 region must contain all digits from 1 to 9, and the numbers outside the grid correspond to the sum of the digits in the corresponding row or column. So the boxes, the 3x3 boxes, are regular Sudoku 1 to 9 normal. The rows, though, are obviously, the rows and columns are obviously not going to be normal in any way, because we had totals of 68, 27, etc. But since we know that each of these 3x3s are in fact totaling 45 each, then we have 135 total of digits in these 3 rows, right? So we can find our missing numbers here by simply adding what we do have, which is 78, and then we would need 57 more to reach 135. 48, 57 are 105 plus 30, 135. So we have 49 and 68, which is 117, and we need 18 more. We have 26 and 41, which is 67. So this will be 68. And here, 56 and 34 are 90. So those will be 45. 27 and 64 is 91. So those will be 44. And 48 and 22 are 70. So these will be 65. So that should be our totals. 70. Okay. This 18 is very, very low. In fact, if you were to have the minimum in all of them, you would get 18. 1, 2, 3 is 6. You cannot go any smaller than that. So that row must be at the minimum. That also being said, the 22 now, if it was also 1, 2, 3, 1, 2, 3, we would have 12, and then these two have to be 4, 5, which is 9, which is 21, and that would have to be minimum as well to make 22. So that's going to look like that. On this 64, we have a small number here. If we have 7, if we're maxing these out as 789 and 789, we have 48. And then if we had a 98, 48 plus 17 is 65. Okay. If I had 789 here, 789 here, that would be 48 plus 17, that is 65, and that would have to be 3. This is all maximum, so these were 789s, these were 89, and that has to be 3. Oh. Yeah, I mean, because we can't go any higher than that. So yeah, that I do feel like that has to be correct. There's no other way around that. But now, we do have a 4, 5 there. Now I think I looked here at this. This would be 5, 6 at the maximum. And then we could have, so that's 11 plus 24 maximum, 35 plus 17 is 52, and then we need 12. If we max out all of these cells, the highest they can be, then we have to have 12 still. And the only way we can reach 12 with those two is if we max them out as well. So that has to be 9, 3. And these were 5, 6. These were 8, 9. And these were 7, 8, 9. Now this away, if we had 7, 8, 9 here, which is 24, 7, 6 are our highest numbers here, which is 13, 24 plus 13 is 37, plus 17 is 54, and we need 14 more. And the only way we can do that is with a 9, 5. That makes that one 8. And these were 7, 8, 9. These were 7, 6. And these were 8, 9. And on, what about this 27? Because this is 3, 4. At the, or no, it's 1, 2. That was 1, 2. That would be 3. That could be 4 to make 7. 1, 2, 3. 7 plus 6 is 13. And then we would need 14 more. Which would have to be the minimums. Okay, so if these are 1, 2, and that is 4, and these are 1, 2, 3, then we have 6, 10, 13, and we need 14 more. So it has to be 7, 6, and 1. 7, 2, 5. Okay, so those are all minimum. And that gives me an 8 there. This is also going to force this into 4, 5. Well, it's going to do that whole line, I guess. 4, 5. I don't. Let's go ahead and try. No, I don't want to do that line yet. Oh, well, maybe I could. It's not going to give me a number, though. Maybe this one. Because this is 4, 5, 6, obviously. It's the only thing that is left. Which is 15. And this is 17. Which is 32. We have 17 left, which is 4, 5, 7. But that's not right. $17 plus 15 is 32 plus 17. Yeah, that's not right. Let me back up to that middle column. Because I feel like if this is 1, 2, 3, we're at 6. This is 1, 2, we're at 9. If that was 4, which would be the smallest it could be, we're at 13. And then we need 14 more. Which would have to be 7, 6, 1. Seven, 6, 1. So this is 3, 4, which is 15. Plus this one, which would be 29, and then 15, which that one adds up. 4, 5, 6, 15, 20, 9, plus 15. So that one is correct. I don't think this one was, though. This would be 7, 5, 4. But this was supposed to be a 4, 5. Was it not? I put the wrong number here, I think. Did I put the wrong number there? Why is that 6 there? Look, that is a 4, 5. If this is 7, 8, 9, and 6, 7, 24 plus 13 is 37, plus 17 is 54, and then I need 14, which is 9, 5. Then for my up and down, it was 1, 2, 4, 1, 2, 3, 7, 6, 1. Good. That part was good. That part was all good. 8, 3, 4, 4, 5, 6. That part added up. That is 5. That is 4. Now we have 7, 6 here. 4, 5, 6 here. So 15, 20, 32, 17. We do have 17 there. Okay, good. Okay, for 26, if this was 1, 2, 3, we would be at 6. If this was 4, 5, we would be at 15, and we would need 11. 5, 6, 7, 8, 9. Don't think I'm ready for that one. $65. This is 7.6 maximum, which is 13. This is 24 maximum, 37. 37 plus 19 maximum still. 37 plus 19 is 56, and that would have to be 9. And that is all max. So that is what we do. That is max, 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 max. 6, 7, max. So we have 8, 2, 6. This is for 5. This is 4, 5, 6. We can just double check. 15 plus 16 is 31, plus 17 is 48. And now, if this was minimum, 1, 2, 3 is 6. If this was minimum, that's 17, and then we need 9, which is minimum. 1, 2, 3 is 6. 6, 10, 11 is the minimum we can get there. Just 17. And then we need 9 more, which is also the minimum there. So everything is minimum. Okay, we have 4, 5, 6 left over. None of these are going up and down. What about 56 maybe? Or 57. That's even higher. Let's try 57 first. That's the higher of everything. If we had 7, 8, 9. Alright, let's just take all maximum. 9, 15, 18, 24, 27, 36. Oh, that'd only be 21. Let's take minimums here. 7, 11, 12, 15, 16, 23. That one's really close. That one is really close to having to be 1, 2, 3. This one, 11, 12, 24, 10 left over. Which one of these have? These all have one of each. So minimum here is 24. Oh wait, did I do that wrong? The minimum here is 24. That's 7, 11, 12. I had it wrong again, didn't I? 7, 11, 12, 16, 17, 24. Those are all the minimum numbers. So these are stretched at 1, 2, 3. Everything is minimum. That is 7, 4, 1, which is 12. It's going to be 12 here as well, because they're all minimum, and then 6 left over. I think what I should do is add correctly from now on. So those are like that. And now we probably go maximum this way with 9, 15, 18, 36. That's 21. So not quite. Okay, then what about this 56? Because it has to have a 1, 2, 3 there. So here we have 18, 36, 36 plus 17 is 53. 36 plus 17 is 53. That is everything being maxed, and that would have to be maxed as well. So these are maxed at 8, 9. Max, max, max. All the way down. And that is 18 times 2 is 36. 39, 17 is 56. Okay, good. No 3, no 6, no 9. Okay, so now we got a high number-ish here. So then let's go back to the minimum 8, 13, 15, 30, 8, 4, 5 would be 9. So close. Very close. Maybe this 34 then. So that would be 7, 11, 12, 24. Yeah, that's it. So 24, everything minimum. This would have to be 4, 5, which is 9. And then plus 1 is our 10. So everything is minimum up and down here. And that is 12, 24, 10, 34. That works out. So that is 2, 5, 2, 8, 2, 5, 8. Hey, this is turning into like a modular thing too. 1, 4, 7, 2, 5, 8, 3, 6, 9. Not everywhere, but it did there. Oh, here's... Oh, yeah, it's kind of random. Hit or miss, it looks like. That's interesting, though. Okay, anywho, this one is going to be a 6, 7. So one of these, those should just work out. I think all of these are done, in other words, and now we go this way. We'll go with the high one first. So maximum is 18 times 2 is 36 with 21 left. Which is max. So this whole row needs maxed. So that is 9, 6, 3, 6, 3, whoops, 9, 7, 5, 9. So that, just to make sure, is 21. No, I'll do it from this side. 18 times 2 is 36. 45 and 12 is 57. Alright, and I think that we just plug in the rest along the top, and we should be good. That was quite the thinker there, Patrick. Very nice puzzle. There will be a link below. Check it out yourself. Give it a try. Ooh, maybe not. I don't know if this is correct or not, but it feels like it is. Let me check this. 15, 30, 48. So I mean, it didn't say. Let me check here. Okay. I assume that this is correct. I don't know for sure. Usually it has to pop up and says how many people have done it and whatnot, but I think that it is good. So yeah, there you go. If it's not, Please do let me know that I was wrong somewhere. And but check it yourself in the link below, and like and subscribe if you enjoyed. And thank you so much for watching. Have a great day, and bye bye.